No,
Easier if you sit.
better.
Okay.
Well, thank you, Chris, and thank you all for coming, and thanks for all of you watching online, hopefully. Right. So I've tried to cover as much as possible with my slides. I'm not sure if I'll get through them all, but we might go into just flash card mode at some stage.
Just get rid of that. Okay, good.
Thank you. That's a big improvement. Right, so here we go. Maybe not. Is it? You wake it up then.
Sorry, it was going to sleep earlier. You kind of need to. You can practice it as many times as you want, and when it comes to the thing, it doesn't want to do it then.
Yeah. That one.
Try it with. Lost the mouse.
Yeah, try that little arrow in the corner there. See the little arrow in the bottom left-hand corner.
Right. Right. Down and left.
Can't even see the cursor.
Are you almost there? Look at it on the screen. Do it on the screen a minute. Once you click it into the first one there. There it goes.
Have we gone too far
It
now?
might now then work.
Yeah, it'll work now.
Once
Okay.
you clicked it
Yeah.
in, it works.
Thank you. Right, so what is so special about the geology in Pembrokeshire, you may well ask? Well, it has got a very wide range of rock types covering quite a considerable time period. It's obviously got amazing exposure around, well, the coast path is nearly 200 miles, but if you take out all the little headlands and everything, if you put them in, it's a lot more than that. And then you've also got the coastline of the Milford Haven waterway. So it attracted the attention of some of the greats of the geological establishment early on. Henry de la Beche, or should that be Beach? I'm not sure. And Roderick Murchison. And we see top of the screen there some of the geological maps produced by Henry de la Beche, and they are not that different from what you see published today by the British Geological Survey. So quite amazing what was achieved at that early stage. In terms of Murchison's work, it was a collaboration, not acknowledged very openly, with his wife, Charlotte, who was a geologist and he was a soldier. So she introduced him to geology. And basically, she was better at drawing than him. So all the sketches are hers, the field sketches. So this classic feature at Stackpole Quay, the synclinal fold. There's a sketch of it. I mean, if I had to be critical, it's too arty, really. It should just be a line drawing with the key geological features accentuated, much too arty, especially the boats in the background. But there you are. We'll let her off. But 200 years before, George Owen of Hentlys in North Pembrokeshire had already been on the case and had noticed, in amongst other things, one side of the pill you shall perceive the limestone, the other a red stone. This vein of limestone, I think that should be outcrop, is very broad, and forthwith it goeth. It reaches to the sea, both in Pembrokeshire and Glamorganshire. So basically saying that limestone outcrop crosses South Pembrokeshire, and it's the same stuff in Glamorgan, which is pretty good. 1602 he wrote that. Very good. We're impressed. No, it's not just me that thinks it's amazing. Carlsberg County, I would say, in terms of its geology, probably the best geology in the world. The JNCC, when the Geological Conservation Review took part, looking for what was nationally or internationally important about geology in our geology in the whole of the UK, selected all these yellow areas to be designated as geological features of SSSI. And there are sites which are too small to be seen at this scale of map. So well, you can see that large areas of the coastline are covered. Quite substantial sections of coastline. Might have been quicker not to just do the lot. Now, students have been coming to Pembrokeshire for a very long time, especially from Swansea University, right up to the present day with Geraint and Danny McCarroll. Are you still coming to Pembrokeshire, Geraint?
Yeah.
Yeah.
It's now taken over from me.
Right.
Still bringing people, yeah.
Wow. Yeah, good. And I very often come across, you know, coach loads of students with their yellow helmets and their high vis. University of Liverpool, Leeds, coming down Easter time particularly. And no doubt all those people's work has been helped greatly by the publications from the South Wales GA, the two geological excursion guides, the old black one and the nice 1982 new blue one. And my own part in teaching, as Chris mentioned, basically I started off with the Field Studies Council, just part-time with the teaching. I had another job, but my part-time I was teaching from about 1979 onwards, field courses, and I also worked with lots of other organisations, including National Park, Darwin Science, Outdoor Charter Group, and the National Trust. Now, if we look at the interval that we've got there in Pembrokeshire, represented by the solid geology, although it's quite substantial, it's only a little tiny fraction of the entire time period from the first rocks, the oldest rocks. So we've just got this, we've got this little bit up here, that's what we've got, and nothing from 300 up to the present day. Thankfully, because I don't like them very much, we haven't got anything that might have a dinosaur in it, so great news for me. I think, unfortunately, and it's been said about me, but it wasn't said to my face, but it was reported back to me fairly quickly afterwards. That Sid, he only knows about stuff that happened millions of years ago. What use is that? Okay? Well, I can tell you, I know stuff that happened hundreds of millions of years ago, but most of what I do is actually practical stuff to do with present day issues. So, yeah. No thanks for that comment. So if we look at the stratigraphic column and we look at the geological map, the older rocks, starting from the Precambrian up through to the Ordovician, they're all up there. And the younger rocks, old red sandstone up to the coal measures, they're all down there. There's a few complications, but that's a broad generalization of what's going on. And in terms of superficial deposits, well, that's the map off the BGS geology viewer, but obviously at that scale, you're only going to see the big things, the thicker deposits and the more extensive, but pretty much everywhere you go, you'll find some evidence of superficial deposits. And of course, there's a very important soil on top of that. What's left of it, but I won't go there. Modern agricultural practice. If we look at that simplified stratigraphic column, we can see that the igneous rocks, Precambrian, Ordovician and Silurian mainly, early Silurian that would be, and then sedimentary rocks, unless John Cope wants to tell me otherwise. We don't have Precambrian sedimentary rocks, but we've got sedimentary rocks from all the other periods up to the coal measures. And there's low-grade metamorphic effects in the older rocks, but not much happened except that the mudstones and the ashes changed to slates. That's about it, really. So low-grade metamorphic effects only. If we want to look at where those volcanics fit, we've got the Precambrian ones here with intrusive igneous rocks as well. And then we've got quite a few in the Ordovician and some here at the beginning of the Silurian. But the scale of that is not, well, it's not to scale, basically. And then it's a bit more complicated than that. I've simplified because basically you've got these older rocks here in this central zone, and you've got some of the volcanics out here, but generally it's fairly straightforward. And if we go back to that Precambrian, late Precambrian, that's roughly where those rocks were being formed, down by the South Pole, on the northern margin of Gondwana, and soon to be separated from the rest of it by the opening of Iapetus. And in terms of plate tectonics, a sort of Andean type equivalent with oceanic subduction on one side and magmas rising and mingling up to the volcanic landscape. So at the bottom here we have diorite from the Johnston diorite complex and the St. David's microgranite being generated as magmas and some volcanism at the surface. I'm sure you don't need me to remind you the basics of igneous rocks. And excuse that pun, actually. So the Precambrian volcanic landscape, as I imagine it, there are probably experts in the room who'll tell me differently, but a thick accumulation of volcanic ash and larger lapilli, etc., in a sort of, in a thick accumulation somewhere. But we don't actually see, as far as I'm aware, the actual volcanic centers. There's some lavas amongst it. So basically, yeah, they must have been fairly close to the volcanic centers. And typically, fragmental, angular class, so volcanic rocks, poorly sorted in an ashy matrix, or sometimes, little squashed, glassy fragments indicating nuae ardente or glowing ash clouds. And if we want to see the Precambrian ones, they're exposed in the core of the St. David's anticline. So here we see Cambrian rocks on this side, Cambrian rocks on that side, oldest rocks in the middle, St. David's anticline, with the designated with the P in front. And on this map as well, we also see the big microgranite intrusion, which extends from the coast up towards underlies parts of St. David's. And these volcanic rocks are exposed all the way around this headland here, the Treginnis headland. And this is looking southeast across that headland. And as well as the coast, we have all these crags that provide exposures, but they're pretty much brambly and very weathered. So coast is your best, but then kayak is your best as well, because it's a bit difficult to climb down those cliffs. And that's just a typical exposure. And it's not, it's structurally a bit complex, but quite often the volcanics are purpley, but not always. So can't remember why I put that extra one. Yeah. Okay. In those Precambrian rocks, there is some metalliferous mineralization, but I think in terms of things on the scale of Cardiganshire, you can forget about it. We don't have that much. That's a little trial for copper out on that headland. Somebody lost their life there when the bucket fell into the hole or something. Accessible place to look at them is at Portlisky Bay, and very beautiful as well. But unfortunately, everything there is quite heavily altered. I tend to refer to it as Pembrokeshire's Alum Bay, because we have all these nice colours here in this embayment. But it's all alteration. But here you can see a typical example. Look, some of the pyroclastic fragments have survived, and then the matrix around it is all heavily altered. Some of that is a hydrothermal effect from the adjacent microgranite, which is just here in this photo. But it's a lovely place, and if you go at low tide, you can get round to there. But the other thing is that Irish Sea ice sheet sampled everything across that headland and dumped it there in that cliff when it melted, and the sea is doing a great job of washing it all out and polishing it. So you can see all the textures. You get a lovely sample of everything here. Looks really good when it's just wet and the tide's gone down. And then we can see that bay there in the background. And this is the big headland coming out to Carrig Vran, and that is where the microgranite is exposed. So that's a good place to see the microgranite. And within the microgranite, we can see these late stage basaltic dikes. I did clean an exposure by the picnic tables at Porthclais, so you didn't have to walk that far. But the other funny thing there was the erratic, which is on somewhere around here, in all the sort of well, is it gorse? Yeah, it's gorse and heather and a bit overgrown. But there's this erratic which people thought was a meteorite because it was so strange. But we think now it's probably an ultra basic rock, probably from the Clean Peninsula. And the mapping there, which is, revised by the British Geological Survey, was by Cox. Now we come down to the Precambrian rocks in the central belt, if you like, running from the coast here at Tolbenny right across to the Benton Castle, which is about here. So we have the Johnston Diorite complex, which is intrusive part of it, and the Benton volcanic group. And Bolton Hill is marked there, circled, but Zik Quarry is about there, and I'm going to talk about both of those. But if we were to go to the coastline here at Gould Trap Roads, we would see that the Precambrian diorite is on top of the coal measures, and that can't be right. So basically, the Johnston thrust, and we're looking at it sort of, it's dipping towards the south as we look at it there, is bringing the Precambrian rocks up. This is the Zik Quarry, spelt Spike, but everyone local calls it Zik. And in this quarry, the Precambrian volcanics are the purple rocks here. And these are Silurian sandstones, which is what the quarry is trying to work. But luckily for me, you can see the Precambrian volcanics as well. And that's the big, I work in all these quarries. That's the big Bolton Hill quarry complex. It's the old quarry, which is, there's as many levels below the water there. as you can see above. But then there's the new quarry, which is being opened up over there now. And the Johnston thrust runs through, you can see it in the old quarry down there. And then I have traced it across these fields up into this little cutting up there. And again, the diorite is on top of the coal measures. But you don't need to go to the quarry and fill in all that health and safety stuff. You can actually just go to Tenby Beach. Take yourself half an hour to go down there, and then you can go back to the pub. And it's all nice and polished for you. It's pretty much as it came out of the quarry probably 30 years ago, hasn't changed that much. You can see here an intermingling of a granitic magma into the dioritic material. So commonly used for rock armor. Arguably, the actual rockfall hazard there is greater than in the quarry. So, but in the top photo diagram, you can see on the basis of geophysical evidence that the rocks in the quarry are from the Precambrian basement 4 kilometers down and about the same further south. They've been brought up along the Johnston thrust. And that's why we get to quarry them at the surface. And that quarry, Bolton Hill, supplies all the roadstone in West Wales. So, but I'm not suggesting that you get on your hands and knees with a hand lens and try looking at the road. It also produces most of the poured concrete. So we are talking that this geological information that we gather from going on field trips with Geraint and others, it all has practical uses. Geological resources, environmental, all that. You need to know about geology. And there's some people who think they can do it without knowing about geology, like coastal defenses. And well, you just see the mistakes that they make by doing that. Recently, I was involved with several years of getting boulders to the nuclear complex at Hinkley Point. They went by barge, and they were used, first of all, to protect the formwork when the concrete seawall was being poured, and then they were moved to the base of the seawall to protect the bottom from scour. And that all looks pretty impressive, but when it starts working, it's going to work for at least 60 years, and it might take twice as long as that to decommission it. So I don't think that's the end of the story, really, but hopefully I won't have to try and I won't be involved in any future supply projects. And if we go to the southern margin, here we see the old red sandstone on top of the diorites at the Benton Fault. And this is a close-up of this headland here, and we can see these app-like dikes, a bit orangey pink, and they're quite sort of messed up. And that is definitely the situation in the quarry. Everything is pretty messed up. No, I said there's no sedimentary rocks as far as we know, but John should be looking for them. I think they might be there somewhere. But we don't have to go very far. We can go to the infamous backwards of the Llangannog Triangle. You're a brave person if you drive in there without sat-nav, I'll tell you that. Anyway, John and his students discovered these soft-bodied fossils, the so-called Ediacaran things. And he's just given me an update. Was it 563?
563. Yeah.
There you are. So 565 approximately for my, good enough for me. So late Precambrian. Are they jellyfish? No. Okay. They look a bit like jellyfish. Anyway, if you were to get a jellyfish, it needs special preservation. It isn't going to work on that beach for sure, right? So they were buried rapidly by volcanic ash. And, well, I don't know what I'm talking about. This is what I found online as a reconstruction of the marine biota of the town. And feel free to, John, at any point to tell me better. But they were all soft bodies. So by the early Cambrian, we have much more familiar sort of shelly forms. So something significant happened between the late Cambrian and the early Precambrian. And now we can see things that we easily recognise and read about in trilobites in Wales from the National Museum. And in the oldest things are quite small, and probably look something like that. And there's what used to be referred to as a trilobite, but it isn't anymore. Agnostus, the small one, very small, and then the big one, Paradoxides, and they're used as zone fossils. They're not particularly abundant, but they can be used as zone fossils in the Cambrian rocks. Also in the later Cambrian rocks, the lingular flags contain lingulella, the inarticulate brachipod, can't speak for itself, and modern forms very similar on the Pacific coast today. Shallow subtidal or intertidal. Now, when we're up in St. David's area, we need to acknowledge the great work by Henry Hicks. He was a doctor, a medical doctor, but he took a great interest in geology, and then he ran into the establishment, and they weren't very complimentary about him. And I can sympathize with that because I'm a beardy old guy. And the authorities, the establishment, is often not very complimentary about me. But there you are. So Henry and me, yeah, I know how you feel, Henry. But he noticed that over in this little corner here, which I've circled, of St. Non's Bay, there was a relationship between the Precambrian volcanic rocks here and the Cambrian sedimentary sequence. So somehow a marine transgression had occurred from the terrestrial landscape. And what I've done is sketch there, look, of that little cave where you saw it. And I've flipped that round through 90 degrees so you can actually see the relationship. So here are the Precambrian volcanic rocks, and here are the basal conglomerate and the Cambrian sedimentary sequence sitting on top of that. And he surmised, obviously, that a great period of time was missing from in there because these had to lithify and then they had to be involved in some kind of mountain building event. And then they had to be eroded. And by someone else's work later on, we found that even the microgranite intrusion was exposed at that time because the conglomerate rests on top of the microgranite. So that wasn't at the surface either. So there must be a huge time gap there. And that was Henry's idea, but the authorities said, no. So you're just an amateur, that's not right. Anyway, the Cambrian sedimentary sequence, the lower part, the basal conglomerate, which was used for things like millstone, and then St. Non's sandstone, Cardivae shales, which contain the earliest little micro shelly fossils, and then the Caribudi sandstone, which is extensively used in St. David's Cathedral because it's nice and carvable. Feldspathic sandstone, and here you can see that some modern restoration from the old stuff and the recently restored bits. And if we want to, we should be good and include metalliferous mineralization, even though there's not much of it. But if you get your kayak into this little cove here, you can see the mine workings associated with St. Elvis mine. Now, before you, that's a mispronunciation of an Irish word, which I can't pronounce either, but it wasn't Elvis. Anyway, but the German miners who were there in Elizabethan times were familiar with Freibergite and recognized that it would be, but it had a silver content, so that made it more exciting. Now, going on to the Ordovician rocks, because I'm looking at the time. Did we start a bit late? Have I got a whole hour? Hope so. Yes, Ordovician rocks. This is St. David's Head with the layered igneous complex folded, so we see it twice. And at the bottom right there, we have one of the gabbros there with the aligned ferromagnesian minerals. And then offshore, so I think that's St David's Head there. Yeah, so just offshore, we've got Ramsey Island. And this cliff here, which I'm kayaking past, there's my buddy for, it's not safe to go around there on your own, so you need someone with you. Just around there, we've got these fantastic 125-meter high cliffs, and the volcanic sequence is dipping towards the south. You can see the big, thick units of volcanic material here. And that some of those units have this very distinctive raggedy pumice clasts in a rhyolitic matrix. Obviously, it's all silicified now, so it's not loose ash, it's tough. But we got these pumice clasts, so it's very distinctive rock, which we can find lots of in South Pembrokeshire on the beaches. So basically, the ice was definitely coming over Ramsey Island. And then the main intrusion just beneath the seabed, sometimes interacting with the seabed, had brought up some earlier formed crystals. So we have this porphyritic rhyolite, which forms most of that area there. And those things were happening in underwater eruptions like Mount St Helens underwater. So that would have been fun. And here we see some more of the lovely textures resulting. At the top, we've got laminated tuffs. There's more ash in the lighter layers. And then this coarser unit has the lode casts on the bottom. Ask Geraint about that sort of thing. Flow-banded rhyolites, where we actually have the rhyolitic magma trying to move. It's very viscous. And here we got the rhyolitic magma interacting with wet sediment on the seabed. Moving along the coast northwestwards, we've got the black mudstones, now slates of the Aberystwyth Blue Lagoon, the flooded quarry there. But there's still some ashes, tuffs out on the headland here. Those slates, those black slates are not very good quality, so they're mostly used as slab rather than roofing. And it's my weak point here with paleontology, but I'm pretty sure those are all graptolites, and one is Didymograptus murchisoni, and the other one's Didymograptus bifidus, but I think somebody renamed that Artus, so I don't know. I think they were plactonic. Mostly. I've definitely seen one that looked like that, where they were all arranged around a floaty thing, but I couldn't find my photo. It's pre-digital, so. And I believe they're related to a modern sea creature, so they're not actually extinct. It was famous for them, but that was when slate waste was being dumped on the shore regularly to try and protect the cottages, but it's harder to find them now. It's been over-collected as well. Moving up to Strumble area, we see a great thickness in the Fishguard volcanic group of pillow lavas, basaltic underwater eruptions of basalts. But we also see in the lower unit and the upper unit of the Fishguard volcanic more rhyolitic rocks like this, explosively produced breccia of rhyolites. And why was all that volcanic activity taking place? Well, in a simplified version, Avalonia was taking off and going northwards across Iapetus. So as Avalonia was going towards the rest of these, which were up there now. And so we got, in terms of Pembrokeshire, we've got the Trefgarn and Ramsey Island and Fishguard volcanics. In the early Ordovician, then we've got the Skomer volcanics in the late Silurian, and at the very end of the Silurian, we've got the oh, I've got a message here. Configuration is pending, but you can't see that, so we'll just continue. All right. National Museum of Wales. No, I don't want to cancel anything. Right, okay, I'll leave that there. You can't see that, that's good. So thank you.
Worry about.
Indy's on tech rescue again. That's the third time today.
I can't get that to do
No,
it.
that's okay.
Ignore it.
I am ignoring it. Yeah, that's good. Okay, so we've got this slightly more, gives you a bit more sense of what was happening in the Welsh Basin, but a fault-bounded back arc basin kind of volcanic environment. So with lots of underwater eruptions and probably occasionally emergence, but we don't often see the evidence for any emergence. There is some occasionally. And I drew that thing to try and illustrate the complexity of the underwater eruptions. This one just has rhyolite in it, but there were basaltic eruptions as well, so it would be more complicated than that. And then if we go beyond, there's the Strumble Head, and these are the Fishguard volcanics going round towards the Phoceles, and then heading around Cardigan Bay towards Cardigan. We have, mostly turbidites. I believe they can be quite interesting, Geraint. Whole field trips. They can be made interesting by the right person. Thankfully, they're nearly all inaccessible around that coastline. But there is some spectacular folding that even I can see, which came later in the Caledonian orogeny. But we see here the sandstone mudstone association of the turbidites. And I believe that a modern equivalent is the Monterey Canyon and submarine fan. So material leaving the shallow shelf, coastal shelf, and heading off into deeper water, sometimes through submarine canyons as gravity flows of dense sediment water mixtures. And if we go to Poppet Sands, we can look at the turbidite sequence and consider whether or not they conform to the idealized Boomer model. Do they, Geraint?
Some of them do.
Some of them do. Yeah, that's the conclusion I came to, actually. But in the quarry I'm working in, quite a lot, you can see the coarse debris and the rip-up class were formed when these sand flows roared down the canyons at 20 miles an hour-ish, maybe. I don't know. Geraint, you're not answering. Okay, but in the quarry, unfortunately, they're trying to work sandstone units, which are in a big mess, really, because I think it was a canyon-like edge, and so it's really horribly complicated trying to work out where the sandstones go next. And the BGS have thankfully made me a little diagram, so I don't have to try and explain that about what was going on in the submarine canyon, fault-bounded. It's complex. And we mustn't leave Poppet without mentioning the reason why it's a geological conservation review site is because of its quaternary landforms and deposits. Nothing to do with the turbidites and or the folding, just the stuff on top. The Ipswichian 125,000-year-old shore platform, relict beach. I don't like to call them raised beaches because I'm not sure they have been uplifted. I doubt it. Inland from there, we have very extensive sand and gravel deposits. I believe Geraint has written a paper on Trevigan, so you'll have to ask him. But originally interpreted as eskers, because they're sort of ridge-like, but then are they fluvial glacial deposits of the outwash plain rather than an esker? Yeah, okay, good. But they're people want them because it's sand and gravel for construction purposes. The other amazing feature from the Ice Age, and I know I'm flipping about a bit here, but geographically it makes sense, is the meltwater channel, probably subglacial meltwater channel, various lines of evidence for that, which goes around from Newport right round and back out Abergwaun. And then there are other parts of that complex heading down here and down here. It's a very spectacular. There's Abergwaun, Fishguard, old harbour, and it's going round there, round the back of Carningley. Here's the central part of it. There's the Preselles to the south of it, or southeast of it. And there's the meltwater channel. So it's a very, very impressive feature. And we can see it there in this map as well. But now we're going to go and look at why is the Preselles like that? Well, there's the main Preseli Ridge. These red intrusive masses within the slate are mostly dolerites. So there's a polished sample of dolerite there. So they're ramifying the slaty uplands, if you like. If we've just got slates, it was rather rounded by the passage of Irish sea ice. There was one place that may have developed a small glacier in the highest point here on the east side. That still holds snow in the middle of winter for quite a while. There probably was an ice field there in the glacier, but all the mountain glaciers were elsewhere. And the Irish Sea ice sheet was being fed by those mountain glaciers in Snowdonia. Not allowed to call it that anymore. The Lake District, even northwest Scotland, and on the other side of the Irish Sea, that was all feeding into the Irish Sea ice sheet. And sometimes going over the top of these hills and sometimes just butting against them. But in the Rosebush Quarry, we can see extensive slate workings, and that's because the slates are a bit better quality, and that was because they had a component of volcanic ash in them, so they make better slates. And then there's various crags sticking out up on the Preselles of Ordovician intrusions or volcanics. Carnarlo to the north here of the main ridge, that's rhyolitic, and then Carnminy, which used to be famous until archaeologists decided that wasn't actually the quarry where the bluestones came from. That's the spotted dolerite. Now they think it came from there. And I'm not going to get involved in that debate because basically there's a lot of bad things going on at the moment between the people on either sides of the argument. But I will, the typical spotted dolerite, night sky, perfect for the job, really, if you're astronomical observatory. But I will just say that you should apply Occam's razor to the argument. So basically, there's enough evidence on the site that something was moving it that wasn't human beings, all right? So, and we put that together with other findings from the Geological Survey. It doesn't really add up to people carrying them away. But like I say, I'm not getting out of that. Right, go to the Skomer volcanics out on the end of the Marloes Peninsula. I need to ask the organisers now about how much time have I got left. Can I go on?
You can go on a little bit longer, yes.
That's good, because I got loads more stuff. So anyway, so in the Skomer Island here, we have southward dipping units of mostly basaltic type lavas, and then that outcrop extends right out to the Smalls Lighthouse, which is way over there somewhere on this scale. But you've also got some of the volcanics on the Marloes Peninsula and over to the Dale Estuary. And that's what it looks like from the air, from the northwest. And these ridges represent some of the harder units within that. They're the escarpments, the scarp faces of the harder units. So it's the oldest ones at the north and then the youngest ones at the south. I like colouring in, so I did that. Okay, might not be that professional and it's all handwritten, but there you are. So that's the sequence of things. We got rhyolites at the bottom, some rhyolites in the middle, rhyolites at the top, and the rest is mostly basaltic, but we do have some sedimentary units within it as well, recycled volcanic rocks. And if we try to think what kind of environment might have produced those uniform sheets of lava, it might have been fissure eruptions, it might have been eruptions from cones that we don't see onto a flat area. It seems that there might have been some interaction with the sea, either with the lavas or just directly when they were still hot or afterwards. There was the Tom's house, the rhyolites there they have these bubbly features on that scale. And then there are like football-sized lumps within them over there, which probably something to do with devitrification. And then there's also evidence in the Skomer ignimbrite of some more explosive activity associated with the rhyolites, so the Skomer ignimbrite. And then looking back across to the mainland with Marlow Sands is very famous and much more accessible, but there aren't many volcanics there. The volcanics sort of are becoming less of the sequence as we go in that direction. But on the departure point for the Skomer belt, we can see these pink rhyolite boulders. So that must have been some recycling on the shoreline of the original lavas. And I've done this, I don't mind the odd sketch now and again, trying to illustrate what was happening on, it might have been a volcanic island, or it might just have been a volcanic shoreline. So there were lots of things going on. And then there was shallow marine conditions, possibly lagoons around the edges of it. And when we get to Marlow Sands, which I must say, the cliffs are extremely dangerous, so don't go there at high tide because you're in the danger zone. The minimum safe distance equivalent to the height of the cliff. So basically, the tide's in that far, that's not safe at all. But here, if you look carefully, you can see lovely ripple marks, symmetrical ripple marks. So that means tidal influences taken together with the crinoids that are there. And in the coralliferous group, there are lots of solitary corals, some colonial corals like Favosites, but also brachiopods. In some of the silurian rocks, orthocones and even the odd trilobite. Usually just the bum end. I think the polite word for that is pygidium. For some reason, that is what's most commonly found. And that diorama, which I got somewhere in a book, was far too psychedelic, so I made it grayscale. Okay. Far too psychedelic. Now, moving on to the Old Red Sandstone, which came next. Yeah, okay, so abalone had crashed into Laurentia and made Laurussia. Anyway, so we have this hot and seasonally wet environment. No vegetation to be seen in this aerial view, but it's coming soon. And sometimes quite complex fluviatile systems. And the consequence of Avalonia crashing into the other continent was that the Caledonian Mount, it was the final phase of the Caledonian orogeny. And those are the same faults we saw earlier from the air up in North Pembrokeshire. Now, in South Pembrokeshire, the Old Red Sandstone is beautifully exposed on the coastline from where I live at Freshwater East round to Scrinkle Haven. And, you know, you've got fairly accessible coastal exposures that you can scramble down, and there's sort of the strike is going that way. So you've got a chance to look at lateral variations, all kinds of things. That's why it's a geological conservation review site. But for that map, that lovely map down there at the bottom, beautifully done. In the early 1900s, we have to thank this man, Ernest Dixon, who was working for the Geological Survey. And he also collaborated on lots of other maps of that area and memoirs, and the standard was extremely high. And I often think of him looking down on me and thinking, look, I sorted all that out 100 years ago. You got the book, what else do you need? You can't find what I told you about. But thank you, Ernie, for all that great stuff. Now, at that time, Freshwater East, we have got plant fossils, and there is a book in the museum, Plant Fossils of Wales, which these pictures are from. But looking at the size of a pinhead, they look for scale. They weren't that impressive, but greater things were to come. And I haven't seen the evidence myself, but apparently there were giant fungi, and the red bar is human for scale. So don't have nightmares about giant fungi. And there was volcanic activity still because we have the Townsend Tuff, which marks the Silurian Devonian boundary approximately, which can be traced from Pembrokeshire through up here into Shropshire. And at Freshwater East, we find bits of fish, like fish spines. So there were fish about. We find trace fossils like this paired trackway. There's the other side of the paired trackway to do with Eurypterids. At Freshwater West, where the old red sandstone is very well exposed again, the entire sequence, apart from the bit that's missing in the middle when the last Caledonian phase occurred, so there's no deposition or it was eroded. We've got these beaconites burrows, so infill burrows, trace fossils of something that might have looked like a massive centipede. And the burrows are about the dimensions of my arm, so quite an impressive centipede. And then carboniferous limestone, which you all know a lot more about than I do, but shallow water marine again now. And if you were to unfold it all and lay it out nice and neatly, the thickest part of that would be higher than Ben Nevis of what we got in Pembrokeshire. And then at the other end up here, look, in one of the quarries I work in, there's an unconformable relationship between the old red sandstone and the carboniferous limestone, and the sequence is greatly attenuated. And around the Tenby, Pembroke area, there's plenty of oolitic limestone, so there must have been some sort of shallow, sort of offshore wave-washed banks. I'm not sure. That's not you, Geraint, is it? Okay. Oolitic limestone with, I think, bryozoa and crinoid and a bit of coral. But yeah, it's best seen when it weathers out, because it's harder to see the texture in those older limestones. Now, moving on very swiftly, which I must, because I'm looking at my own time scale there. The Castlemartin Peninsula, where that thickest assemblage of limestones can be seen. If you go all the way around that peninsula, you can see them all. We've got a fabulous coastal plateau, which is probably a marine erosion surface, I would like to think. And it's cutting across all the folds and faults. It's got spectacular coastal scenery. Oh, sorry, I should say, I don't know why that's out of sequence. Oh, no. Okay, well, it's definitely out of sequence, but the carboniferous limestone, a very valuable building resource, as recognised by the Normans in particular, when they built all their castles out of it. And here we are on Caldy Island, where there was also extensive quarrying. This is the North Cliff Quarry here. And that had although the workings were quite primitive, as you see with all the wheelbarrows, there's a bit more mechanization where this thing can be pushed out and dumped into the ship. And there was here, next to these aggregate bins, actually one of the earliest concrete block making facilities. And over at Kiln Park, which is in the news quite a lot because of its flooding, there was a battery of lime kilns. So things were getting a bit industrialized, and the railway that went in there joined to the Great Western Railway, so that the burnt lime, slate lime could be taken away, and limestone building materials from the Black Rock quarries. Now, carboniferous, late carboniferous, well, millstone grit and coal measures, deltaic environments down by the equator, the Gulf, equatorial Gulf, and the coal measures probably something like the modern day Niger Delta, but different trees. Now, giant seed ferns, giant horsetails, and sometimes, if you're lucky, beautifully preserved plant fossils. And the coal measures, part of the South Wales coalfield, extend across from Carmarthen Bay to St Bride's Bay. But the earliest industry was actually exploiting the iron ore that often occurs in the seat earths of the coal. The coal was just something you could put byproduct until the age of steam. So it was going to charcoal-fired furnaces to make iron. Some of my ancestors, I discovered, were farmers and occasional coal miners when there wasn't any farming to be done in the Martle Twy area. So I didn't know that when I became a geologist, but perhaps they were directing me towards it. And here at Amroth, we see on the northern edge of the Pembrokeshire coalfield, we see a void there where they were working black band ironstone, so ironstone nodules in shale. And this here is an adit which goes inland for several kilometres and used to drain mines. But this whole coal seam here, one of the thicker ones, is completely worked out by opercasting in the top of the cliff. So it's difficult to see those old workings, hundreds of years old now, but if you look carefully, you can work out. Now, further south, they had great structural complications. So this section at Saundersfoot with the famous Ladies' Cave anticline is just this little bit of the upper diagram. So extremely complex thrust fault complexes. And at Freshwater East, where I live again, so I've chosen this example, the eroded Freshwater East anticline, which is good to try and make students work out what used to be there because you can't see it. And I put this the Alps, not Freshwater East, but it's supposed to indicate what a fold would have looked like that when it was being eroded in the mountains. You could try and work out how big the mountains were by simple geometry, but yeah, there's a lot of factors. So, but if we say at Freshwater East, the top of the modern cliff is there, the top of the anticline was at least there, and there was several thousand meters more rock on top of that. So it would have looked quite impressive. And where is it now? Well, it's been worn away, a bit like the highest mountain in the Alps is being worn away. Well, that's what we got left of these ridges on the harder units of the Old Red Sandstone, so-called ridge and vale scenery. So the lower land in between is the carboniferous limestone, and the upstanding ridges are on particular units of the Old Red Sandstone. So we're at the end of the Carboniferous, we're losing any solid geology evidence. So we've got to scratch around now and go to other areas. So the Permo-Triassic, when Pangaea was created, when the Veriskan orogeny occurred, and we're somewhere in the middle of those central belt. Now, there should have been another photo there, but we do have bits and bobs of what was happening. So we've got these so-called gash breccias, strange brecciated zones of carboniferous limestone. In some of the cave systems, we can see things that are probably Permo-Triassic, may have been washed in there by flash floods. And some of the voids from that time are now at the surface, so we can see very impressive dough lines and things like that. We also miss out on what was happening elsewhere with sort of major extinctions. And well, we've got to try and work out what was happening, but we know global sea level was relatively much higher due to greenhouse ice conditions and also the land being well, the sea being higher or the land being lower in relation to each other. And I mentioned about that coastal plateau, which was one of the, probably the most recent phase of that marine erosion cutting across the limestone plateau at Castlemartin. Thankfully, that was the end of them. Coastal scenery, obviously very famous. You can see it in all the textbooks, but the evidence is that it's not really coastal scenery. It's really reworking of old karstic. Things bigger, as big as Gaping Gill in the Yorkshire Dales. Milford Haven, an amazing feature of Pembrokeshire, all the drainage in that dark green, that's the catchment of the Diaclethi estuary and the Milford Haven waterway. Humans have done their part in trying to fill up those through soil erosion, particularly since the agricultural revolution. The curious bend in the waterway system is to do with tectonic events in the past where a fault scarp diverted it. The Rittek fault, which runs across South Pembrokeshire and could create an earthquake at any time. The last one was 1892, 5.1, so that would have been noticeable. The structural damage was minor, but the waters of Milford Haven were visibly disturbed. Wow. Don't miss that. Okay, Ice Age, very quickly. Am I allowed to continue? Good. Yeah, Britain glaciated, well, northern Britain glaciated. This is the most recent glaciation, sometimes fully glaciated, perhaps. Part of the Scandinavian ice sheet, then sea ice in the winter across to the Great American ice sheet. A bit more detail for the last glacial maximum where South Pembrokeshire was a little sort of tundra-like enclave between the glacier ice of the Welsh mountains and the Irish sea ice sheet on the other side to the west. And in South Pembrokeshire, we can see evidence of periglacial process. So basically, through much of the year, there was snow covered and the ground was permanently frozen, but in the summer, like where I worked in Arctic Sweden and Norway, it might brighten up a bit and let you see some rocks. And in some of the caves, you can see what was wandering around there, the woolly mammoth and some predators like the cave lion, the hyena, wild horses. Wow, that would have been good. Right, when they were dredging Milford Haven, they found a mammoth tusk in the sediment and they were making the basin. Some of the other things they found bones of, I'm not sure they found one of them, but it's good to have it in the slide anyway. But definitely reindeer, woolly rhinoceros, and cave bear. And when it has to end somewhere, so the Ice Age came to an end. And things got a bit serious then, because all of that great thickness of ice melted and the water had to go somewhere. So if we look at Milford Haven, there are some curious features of the waterway, like these deep pools that occur in the upper part. And the profile can't be that of a river because the river would have had to flow uphill and downhill to go over all that. So it must have been under the ice. So subglacial erosion from northward migrating moulins, like this one in Greenland today, and then an ice cave, or a tunnel under the ice, down the deep water channel of Milford Haven. So in most books, it says Milford Haven is a ria, which is a flooded river valley, but they don't mention about the glacial, fluvio-glacial bit. And then at the entrance to Milford Haven, the two channels, one of which the Sea Empress managed to miss completely, the deep water channels were probably formed by glacial diversion, because there's definitely evidence of ice. Here we've got a cane terrace at West Angle. So the ice was there. And so the two deep water channels were caused by glacial diversion of probably subglacial drainage. If we look out across Carmarthen Bay from the limestone caves like Nana's Cave, which was part of the early human occupation of Britain, not the earliest, but before and just after the last glacial maximum. We look out across the Gower to the Gower Peninsula today, Carmarthen Bay, but in the past it would have looked like that when people were looking out of that cave. A nice woodland with huntable things. Well, that one's a bit dangerous, but those are probably better. And that is those called the hominid fossils. Were they Neanderthals? Were they early humans? Someone else could say about that. And then we've got the last glacial maximum there, and then the post-glacial. But look, the in the Ipswichian, which we're talking about, the last interglacial, sea level 6 to 9 meters, perhaps higher than today, but carbon dioxide 270, whereas at the moment we're trying to get well beyond 420. I think we can make 500 if we work hard at it, right? So there's the last natural cycles of the Ice Age, so-called. There is the last Ipswichian, which is, this is at Broadhaven South, where we have datable shelly fossils, approximately 125,000 years old, sea level 6 to 7 meters higher without any human influence and without more than 100 parts per million extra carbon dioxide, plus all the other methane and stuff that we're doing. So I think we can do significantly better than that. And of course, that's post-glacial rise in sea level was recorded in the legends of Cantref Gwaelod. And we can see around the Pembrokeshire coast lots of places where the submerged forest, when the sea level drowned the last bit of that forest. So you don't need me to tell you all this. Oceans are heating up more quickly, ice melt is increasing, sea level rise will accelerate. Not good. And I'm already involved in discussions with coastal communities, which are basically just saying, there's nothing we can do. We're going to have to move. So the whole sorry story of human evolution can be summarized quite nicely in that. So thank you for listening. And I've already warned Nigel that he's only got one question. And usual rules apply. The first question is free, and then afterwards they're at consultancy rates.
We just have just a few minutes of questions, and then we got to tidy up and everything before 5:30. So, any learning questions? I was really grateful to see all these pictures of things which I didn't get access to, like all the quarries and the pictures from the kayaks. And then that amazing picture of the chevron folding up at is it Camas Head?
Oh yes, yes.
Did you take that from a drone, or have you got?
No, that I used to do aerial photography. My son does all the drone photography. Drones hadn't been invented when I did that. So basically, we use Cessna light aircraft with a high wing, but both systems has their advantages and disadvantages. It takes ages to wait for a Cessna for the weathers to be right, yeah, no cloud shadow, all the rest of it. It's tied out, so you can wait 6 months before you. Lots of going to Haverfordwest Airport and being clouded off or whatever. But with a drone, you're not allowed officially, not allowed to fly much more than 100 meters up, and not very more than, I can't remember what it is. My son has all the relevant qualifications and licenses. You can't go very far. So basically, the light aircraft is for doing big distances from high up, and the drone is for doing. It's a lot easier to organize the logistics, but you can only do small areas on each flight. You can only do small areas and not go very high and not very far. Yeah.
Anyway, that was amazing. I've seen ones from boats there, but never that. Any questions?
What about is it the Flintstone clays?
Oh, yes, I forgot to mention that. Thank you. On that Castle Martin marine erosion surface on the limestone, which I showed you, and if you look in the stratigraphic column at the start, it does actually show you a tiny little sliver of oligocene. So on the Castle Martin Peninsula, in the Flintstone clay pits, on the basis of the micropaleontology, they are oligocene clays. So what you can deduce from that was, and they're freshwater deposits, so basically it wasn't under the sea by the Oligocene. It was already emergent. And the Flintstone clay was used in making sailors' clay pipes. Well, anyone could have a clay pipe. Let's not be sexist about this. And lady sailors could have them. But there was also used in ceramics. So it was exported off that somewhat dubious loading platform at the Devil's Cauldron. So it had, as well as scientific interest, it had practical value at that time.
Do we have any online questions?
Not so far, I've just asked, but.
Just one.
I'm taking my lead from Sid for his very kind invitation to me for asking a question on there. I'm allowed one free question. This is from field trips we've been done on that. After that, charges to apply, and unfortunately, I didn't bring much money with me today, so I'll just claim the one free question. First of all, before asking the question, I'd like to
Just there's someone waiting, Nigel, online. There's a question has come in. Quick.
Just to thank Sid for such a great talk here on that, taking us round Pembrokeshire on there. I say this particularly from a personal point of view, because I've had the privilege of attending many of Sid's field trips. In fact, I can say that I've been on a field trip with Sid every year for 25 years. I find that sort of amazing. I mean, he's done trips for the South Wales GA and National Park, but of course, from a personal point of view, I mean, he's done them for the U3A Regional Geology Group, and every year Sid volunteers, converted commas,
Did I?
To take us on the trip. So we've been everywhere on that, and it's such sort of great, memories of the last 25 years. So from a personal point of view, big thanks, to you, Sid, on that.
My pleasure. Well, almost.
Yeah. Now
We've got two. No, that was free. We've got two online questions.
That's an observation.
We can do.
4 minutes left.
Let's do your live question after the online view as well.
The iron nodules in shales at Amroth.
Okay, so most of them, not all, but most of the nodules were mined from the seat earth. So the humic acids released by the peaty material, which subsequently became coal, mobilized the iron from iron minerals within the seat earth, and then it reformed as nodular concrete, well, nodules and larger concretions.
And carbonates, right?
Yes, my favorite type of carbonate, siderite, I believe. But some people pronounce it siderite, but I think that's wrong.
Otherwise, there was a comment that so pleased to hear you subscribe to glacial transport method of bluestones.
And the jury's out at the moment, but like I say, Occam's razor suggests that until someone finds the the shoes and things with a big stone on top of them, somebody lost their stone and got buried by it.
We do have 2 minutes and then that's it.
Yeah. Otherwise, just a general comment of appreciation from several people.
Thank you very much, everyone. Nigel.
Yeah, my
Quick,
question, yeah.
2 minutes.
Yeah, one of the many sort of features, geological features on there, that we've seen on there. One I found one of the most intriguing, one of many obviously, and you did briefly mention it towards the end, and that was of gash breccias.
Okay, yeah, well,
I'm not sure whether they are unique to Pembrokeshire.
no, I don't think so, because you've got breccias which may be tectonic on the Dent fault
Yeah.
in Yorkshire, where I used to teach as well for the Field Studies Council. Let's just say they are polygenetic. Okay, so if you think of well, you can think of a triangular diagram, but you may need to make it 3D really, a big polygon. And at the ends, you've got the end members of how those gash breccias were formed. And in the middle, you've got all sorts of combinations of those things. So they're obviously originally karstic features, and then those karstic features have been modified by various things. And in my own mind, although I haven't got the evidence to prove it, those karstic features were already present by the end of the Carboniferous, and that acidic waters from the Coalmeasure swamps had helped within the formation of those huge voids. But that's just in my mind, I can't prove it.
That's very likely. Ask somebody else.
There was one.
That's another question.
No, it's an appendage.
You're running out of
It
time.
was the possible question of sort of hydrothermal.
Oh yes, I like that. Hydrothermal because of the Lundy microgranite intrusion and the huge basaltic mass underneath the Irish Bristol Channel. We think hydrothermal effects might have been in amongst the
mix.
polygenetic origins.
So we'll draw to a conclusion now. I'll take Nigel's comments earlier as a vote of thanks to Sid for this fantastic and wide-ranging talk, which is fantastic. If anybody is new or comes for the first time, please do come and say hi to us. Otherwise, we're going to the Copper Pot for some lunch. And I believe that, Nick, you have